Hello there. You're listening to Oyla, a science podcast for students. We tell stories that make you smarter. Don't forget to subscribe so you don't miss our latest episodes. You can discover even more about science and the world around us in our magazine, so head over to Oyla to check it out.
Have you ever thought about why we feel afraid? Why do we fear falling from a tree or a cliff? Why are we scared of wild dogs and afraid to fly on planes? From childhood, we're surrounded by a variety of different fears, but they all have a common nature. The brain generates these fears for the sake of a single goal, to protect us from danger. Hello friends, and welcome to Oyla Podcast. Today we dissect fear. Some fears, like aversions to heights or great depths, are engraved into our minds as instincts, unspoken reflexes which were bestowed to us at the beginning of our lives and were acquired throughout the course of human evolution. The roots of such safeguarding behaviors are present in animals that have very simple nervous systems, for example, the ctenophore or comb jelly, and represent the simplest nerve chains. The foundation of fear in humankind is much more complicated. Everything starts with a stimulus, a big exam or a visit to the doctor, depending on the individual, and ends with the release of hormones into the blood, which mobilizes our bodies for survival. There's nothing wrong with the feeling of fear. It's been helping us for thousands of years to save our lives and the lives of our ancestors. Let's say we're peacefully walking through a park. The weather is nice, the grass is green, and the birds are singing. Suddenly we hear a bark. An aggressive-looking dog is rapidly approaching us, and it seems that it doesn't like us. We understand that running away would be futile, but it's not planning to stop, so we begin to imagine how this confrontation will end with blood and pain. So of course, we feel an overwhelming fear. Our palms get clammy, our heart begins to beat quickly, our head spins, and our muscles contract tensely. Even if the dog only scratches us, we will remember this situation for a long time to come. The fear of this breed of dog will stay with us, even if they're just lying majestically in the sun, not looking in our direction. The reason for this lies in the amygdala. This paired area of the brain, each hemisphere has an amygdala, has a distinctive shape in the temporal lobes. In our first meeting with the dog, there was a strong response from the amygdala. Together with the visual segment of the brain and the hippocampus, this area of our brain plays a role in memory, learning, and navigation. An assessment takes place whether such a situation has happened before and how far away the danger is. When the situation is perceived as a threat, the sympathetic nuclei in the brain are activated, which triggers a neural response in the hypothalamus. In turn, the hypothalamus stimulates the pituitary gland, and it produces a substance that, once reaching the adrenal glands, triggers the synthesis of the hormones adrenaline and norepinephrine. Thanks to these hormones, the body mobilizes muscle strength, reaction speed, and endurance, and even increases the pain threshold for a period of time. Physiological manifestations of these processes are familiar to everyone. Breathing quickens to saturate the body with oxygen. The pupils dilate to increase their field of vision. No wonder we have the saying, eyes wide with fear. The heart beats more quickly to nourish the muscles with blood. The blood pouring into the muscles causes a feeling of butterflies in your stomach, enough to induce nausea and abdominal pain if the fear is strong and lasts for an extended period of time. And due to this, the face can grow pale and also experience chills. The blood that was warming the body is now concentrated in the muscles. It's a defensive physical reaction that developed over the course of evolution. At the moment of meeting with danger, our body momentarily mobilizes for survival. There's even a special name for it, the fight or flight response. In an unfamiliar situation, the body reacts instantaneously, running from danger or fighting with it. Throwing punches isn't necessary, it's sufficient just to act decisively. At this stage, an image of the memory is formed and stored in the short-term memory of the hippocampus before being transferred to the long-term memory of the corresponding parts of the cortex. Later, any similar stimuli will evoke the desire to quickly respond to a potential threat. Memories from traumas, such as the survival of car crashes or the horrors of war, can cause a person great suffering, causing them to repeatedly re-experience the traumatic event in their sleep or in their everyday life. This mental disorder is called post-traumatic stress disorder, and the understanding of this condition is a direct application of research on the neurobiology of fear. The better we understand what happens in the brain in moments of fear, the more we can help patients suffering from post-traumatic disorders. Thanks to the knowledge of the neurobiology of fear, American scientists, using the method of optogenetics, which involves introducing light-sensitive proteins into the membrane of neurons and artificially activating them with light, learned to form new memories in mice that are supported by positive experience and are no longer associated with negative emotions. However, fear is not strictly an unpleasant emotion. Many people are ready to pay money to experience it. They buy a ticket to a horror film or take a ride on a roller coaster. So why do we like to be scared so much? The answer may be linked to endorphins, the so-called pleasure hormones. When the brain understands that the situation is under control and there's no real threat, it stimulates a release of endorphins into the blood, and the feeling of fear fuses with happiness and gratification. The pleasure hormones become a nice bonus after we experience fear and tension.
We are happy when our favorite team wins, when we set a new record, or do something risky. Sometimes the feeling of happiness is so strong that an individual gets hooked on the thrill, hoping to experience it one more time. Adrenaline dependency affects many skydivers, sports fans, entrepreneurs, and people in high-risk jobs, such as police officers, firefighters, and soldiers. Research has shown that the absence of a fear response is due to amygdala abnormalities. Although you can turn off fear yourself, it takes a lot of time and training. One of the best examples is the free solo rock climber Alexander Honnold. There's even a term named in his honor, to Honnold, meaning to stand on a cliff and look straight into the abyss. Over many years, Honnold overcame his fear of heights by training on different alpine paths. Every time, he performed all of the possible movements on each point of the trail, including possible unforeseen situations, even falling to the bottom of a cliff. With such an approach, it's as if the brain gets used to all of the terrifying details and becomes certain that a risky pastime is actually completely safe because it's all been carefully planned. Even an ordinary person can rewire their fears. It's quite simple. Every day, expose yourself briefly to the source of your fear in a safe environment. Afraid of heights? Try climbing a ladder more often, not too high up at first, but later advancing higher, while taking precautions. Or looking out a closed window on the 10th floor or higher. Scared of spiders? Just catch one, put it in a clear box, and take care of it. You'll see that in just a short time, the fear will disappear on its own. The brain will understand that the situation isn't dangerous at all and transform your negative emotions into positive ones. Keep in mind, however, that for people with anxiety or other mental disorders, this method should be conducted under the supervision of a mental health professional.
You've been listening to a podcast brought to you by Oyla, a science magazine for students. Please subscribe and check out our website, Oyla, for more information.